name is bin Zurina and my metric number is 01 DKA 22F1140. And next, my friend is Amin.
Hello, my name is Sharif Nurami bin Sharifuddin and my metric number is 01 DKA 22F1125.
And the next one is Nafal.
Assalamualaikum and hi, my name is Muhammad Hari Nofal bin Abdul Wahab. My metric number is 01 DKA 22F1113. I will introduce you my friend.
Hi, very good morning madam. My name is Rizman bin Zainal Fandi and my metric number is 01 DKA 22F1147.
Next, about our tutor is introduction of trigonometry. Trigonometry branch of mathematics that deal with the triangle, mostly with right triangle and used in finding relationship between side and angle. So right now in front of us have model that we made. So the detail and this model my friend can explain about it. So I will pass to my friend Zarul.
Today, the model is about in the airport. We are using crossway to landing the aeroplane in trigonometry calculation to ensure the safety of the passenger in the aeroplane. The material that we use is mounting board as the landing, and the aeroplane is we use the Lego, and the tower is we use the snack food that we buy from the groceries. So I will pass to my friend.
So next, we want to talk about application in real life. So the explanation will pass to my friend Nafal.
Trigonometry in flight engineering. Flight engineer have to take in account their speed, distance and direction along with the speed and direction of the wind. The wind plays an important role in how and when a plane will arrive wherever needed. This is solved using vector to create a triangle using trigonometry to solve. For example, if a plane is traveling at 234 mph, 45 degrees north of east, and there is a wind blowing to south at 20 mph. Trigonometry will help to solve for that third side of your triangle, which will lead the plane in the right direction. The plane will actually travel with the force of wind added onto its course. So the calculation, I will pass to Amin. He will explain about the calculation.
Okay, for the calculation, we just explain about how we find the theta over here. So for more explanation, we go to the next video. So yeah, close. Okay, from here we got our triangle. So like I said earlier, we need to find the theta over here. So the length we just get is 60 meter and the hypotenuse is 120 meters for the crossway of aeroplanes. So what we didn't get is angle of A and length of A. So we need to find these two and we can get the theta. So for the conclusion for the finding the length of A is C equals to square root A square plus B square, and we want to find A. So A equals to square root C square minus B square. So the C is 120 meter and the B is 60 meter. So we calculate it and we get the length, and the length is 103.92 meters. So from that is we can find the angle of A. So the angle for A, the formula is sin C per C equals to sin A per A. So sin 90, for here we know 90 of the length per 120 equals sin A per 103.92, that we got the length from this calculation. So we transfer this length to the move to the other side lah. Easy to say. So it becomes just like this, equals to sin A. And then if you want to find the A, we need to transfer the sin into the other side, and we times it with the answer that we get from the calculation over here. So we get the answer is 0.866. So the answer is 60 degree. So we know over here 60 degree, and this is 90 degree. So for the basic, we know that if this 3 checkpoint equals to 180, so 180 minus 90 minus 60, so we get over here our theta is 30 degree. So that's it.